Okay. Good morning to NEET 2020 aspirants. All of you, very good morning. I think as I told you that, so we have selected 100 questions. So 100 expected questions. In that, I think I explained 5 questions. So one question will come in dimensional formulae. One question will come in dimensional formulae. And one question will come in significant figures and percentage error. One question will come in significant figures and percentage error. And one question will come in instruments like Vernier calipers and screw gauge. I repeat, one question will come in dimensional formulae and one question will come in significant figures and percentage error, and one more question will come in instruments like screw gauge and Vernier calipers. So 3 questions will come in the first unit. And next in one dimensional motion, so average velocity. So in 2019 they asked one question in average velocity, that also I explained. And in 2-dimensional motion, so 2-dimensional motion, 5th question, they will ask in relative motion. So I keep the heading relative motion. So what is the relative motion? That now I am going to explain. Be careful about this relative motion. One question will come in this relative motion. Okay. So relative motion. What is the relative motion that we can see? Okay, right. Now you see, this is car A. You take it is car A. The velocity of car A is VA. So this velocity of car A is VA. It is moving in this direction. So this is car A. Next, you take here car B. So this is car B. Okay, the velocity of car B is also in the same direction, VV. So this is velocity of car A and it is velocity of car B. You take velocity of car A, for example, you take 8 meter per second. And you take this velocity of car B is 3 meter per second. Okay, so both are moving in the same direction. So car A and car B both are moving in the same direction. So this is velocity of car A and it is velocity of car B. Okay, now the question is, what is the velocity of car A with respect to car B? Velocity of car A with respect to car B means we are giving respect to car B. So how you give the respect means you make the velocity of car B as 0. You make it to 0. How you make it to 0? See here. So this is the velocity direction, velocity of car B. Is it direct? Is it correct? Now in this you can add in opposite direction that same VB means minus 3 meter per second. Can you understand?
Yes, sir.
If you add vector here, you can add for this A also. So for this also you can add in this direction velocity of car B, that is minus 3 meter per second. Is it correct?
Equal and opposite.
Yeah, opposite direction, equal and opposite direction. Very good. Now see here. So this is plus VB, it is minus VB. These two gets cancelled with each other. So velocity of car B in this case is 0. Now what is velocity of car A? Means velocity of car A with respect to car B, VA. That is nothing but VA minus VB. Is it correct?
Yes, sir.
VA is in this direction and VB is in this direction. So velocity of car A with respect to car B, that is VA minus VB. So VA minus VB means that is equal to 8 minus 3. That is equal to 5 meter per second in the same direction. Is it correct?
Yes, sir.
So what is the velocity of car A with respect to car B means plus 5 meter per second. Plus indicates that it is moving in the same direction. So this is a relative motion. Relative means one and another. We are comparing one vehicle, one object to the or one quantity to the other quantity. So we are comparing velocity of car A with respect to car B. So this is the relative motion concept. Very, very important. So based on this relative motion concept, so this is the relative motion concept. So now Based on this relative motion concept, we go for rain and umbrella problem. We go for rain and umbrella problem. Okay, please take it. Have completed?
Yes, sir.
Right, good. So now we see rain and umbrella problem. So compulsory they will ask question in this rain and umbrella problem. So rain and umbrella problem. Rain and umbrella. Rain and umbrella problem you can see. Now see here please. Suppose, listen, rain is falling vertically. Always rain is falling vertically with a velocity of VR. Assume like this. Rain is falling vertically downwards. This is the rain velocity. Rain is falling vertically downwards. Okay. Now, man is walking on the road like this. So he is the man. So man is walking on the road horizontally in this direction. So he is the man. So man is walking on the road horizontally. Rain is falling vertically downwards with velocity VR, and man is walking on the road horizontally. Now, in which angle he has to hold the umbrella to protect from the rain? That is the given question. Question is, rain is falling vertically downwards. For example, you take rain is falling vertically downwards with a velocity of 3 meters per second. Example. And man is walking on the road horizontally with a velocity of 4 meters per second. Okay. Now the question is, first question is, find the relative velocity of rain with respect to man. Relative velocity of rain with respect to man. And the second question is, with what angle he has to hold the umbrella to protect from the rain. With what angle he has to hold the umbrella to protect from the rain. So that is the second question. So these two questions we have to see. Okay. So these two questions we have to see. So these two questions we have to see. So to make it, what we have to do? So to make it, what we have to do? Yes. So to make it, what we have to do? Please tell me. To make it, relative velocity of rain with respect to mass means man velocity you have to make it as 0. Means you can add in this direction man velocity Vm. Is it correct or not? 5 minus 4 meters per second. Yes. If you add here, you have to add for this vector also.
Yes, sir.
Yes. So you can add in this direction. Very good. That is V man, that equal to 4 meters per second. In this direction I can add it.
Yes.
So these two gets cancelled with each other. Now this is the rain velocity and it is the man velocity. This is the resultant velocity. Any doubt regarding this? So here I am drawing the resultant velocity. See here. So this is the resultant hypotenuse like this. So example you take, it is A and it is B. Okay, it is hypotenuse.
Yes, sir.
Root over VR square plus UX square. Is it correct?
Yes, sir.
So what is the resultant? So this resultant. So V rain with respect to man, that is equal to root over VR square plus V man square. Like this you have to find it.
Hypotenuse.
Hypotenuse. Right. So this is the hypotenuse. Very good. Okay.
Yes.
So now you know this is angle is 90 degrees. This is 90 degrees.
Yes.
Now this angle you have to find out. This is the resultant rain. So it is the relative velocity of rain with respect to man. So the man has to hold the umbrella along the hypotenuse direction. So he has to hold the umbrella. See here. This is the umbrella like this. So he has to hold the umbrella like this to protect from the rain.
Rain.
Okay. So this angle you have to find out. Simply you can find it this one. You know. So this is 90 degrees. This is 4 meters per second. No? Means this is 53 degrees. 53 degrees. And this is 3 meters per second. No? This is 37 degrees. 37. 53 plus 37, 90. 90 plus 90, 180 total. Like this. Now, with what angle he has to hold the umbrella? Means he has to hold the umbrella with cos theta is equal to, see, cos theta is equal to 4 by this one you can find out. What is this one? Root over VR square plus Vm square means, so that resultant velocity you can find out. That is equal to root over 4 square. Yeah, very good. 4 square plus 3 square, that is equal to 16 plus 9, that is equal to root to 25, that is equal to 5 meters per second. Right. So this is 5 meters per second. Any doubt?
No.
Right. So cos theta is equal to adjacent side, that is 4 divided by 5. Therefore theta is equal to cos inverse of 4 by 5. Or theta equal to 37 degrees with respect to horizontal. So two questions I explained.
Yes.
So What is the relative velocity of rain with respect to mass? Means that is 5 meter per second. Okay, resultant vector you have to find out. Okay, right. Why? Because this is in this direction, this is in this direction. This resultant you have to. In previous question, both are in the same direction.
Same direction.
So because of that, we have taken VA minus VB. But here between these two vectors, we have the angle. So for that, I have taken this one.
Yes, sir.
Any doubt regarding this?
No, sir.
So resultant vector I have taken. So that is VR square plus VM square, that is 5 meter per second. So this is one example. So this type of question also will come. We are expecting this type of question. Okay. So we are expecting this type of question. One question in relative motion, two-dimensional motion. Okay. Right. So relative velocity of rain with respect to man. Now one more concept here only. So please take it. One more concept is there, that also I will explain here. One more concept is there. Completed?
Yes.
Right. So boat and river problems. So in that we have two cases. One is shortest path and second one is the shortest time. Shortest path and shortest time. Two cases are there. Now I will explain one case. That is shortest path. Here we take boat. Boat and river. River problems. In 2019 they asked one question. In 2019 they asked one question. So here we have two cases. One case is shortest path. Shortest path. First case is the shortest path and second case is the shortest time. Shortest path and shortest time. Okay. Now we see for shortest path. We see the shortest path. So what is the shortest path that we can see? So in boat and river problem we have two cases. One is the shortest path and second one is the shortest time. Right, very good. So now you see the shortest path. So shortest path you see. Be careful. So this is the rain. This is the river. So this is the river. This is the river. Assume the width of the river is D. This width of the river is D. D is the width of the river.
Okay, sir.
Now, river is flowing in this direction. This is the direction of the river. Means in the left to right. So this is the river direction or V water. This is. So V water. I am taking V water. River is flowing in this direction. Okay. Man is at the bank A. Man is at bank A. In this bank A. He wants to reach exact to the opposite bank. He wants to reach exact to the opposite bank. Exact to the opposite bank. Okay?
Yes, sir.
So river is flowing in this direction with velocity VW and man is here at bank A. He wants to reach exact to the opposite bank. In which direction he has to swim? And with what angle he has to swim such that to reach exact to the opposite bank? That we are going to find out.
Yes,
right. So how to find that? See here. So to reach exact opposite bank, he has to swim in upstream direction. Why upstream direction? That I will tell you. Please listen. Suppose he will swim in this direction. Listen. This is the man velocity. And you know this is the river velocity. Means V water.
Yes, sir.
So it is river velocity and it is man velocity. Resultant velocity will come here. And if you check again here at this point, water velocity is in this direction only. Man has to swim in this direction and resultant velocity will come in perpendicular direction. Can you understand? Any doubt?
They are 90 degrees, sir. It is angle.
Which one is 90 degrees?
Resultant vector.
Yeah, resultant vector always makes with respect to this water 90 degrees. That I will tell. Right. Now also you can see here. This is the water velocity. And man has to swim in this direction. Resultant velocity will come. Resultant velocity always makes an angle 90 degrees with respect to this horizontal. Like this. Now you can check here. This is the water velocity and it is the man velocity and it is the resultant velocity. Like that he can reach the exact opposite bank.
Yes, sir.
Can you understand?
Yes, sir.
So he has to swim in upstream direction to reach the opposite bank. So he has to swim in upstream direction to reach the opposite direction like this. upstream direction like this. This is the V man. Can you understand?
Yes, sir.
So this is V man and it is the V water. Any doubt regarding this?
No, sir.
Now what you have to do? This angle you have to find out. Listen. So they'll ask you this angle. Suppose they'll ask this angle theta. Means this theta is the angle made by the man perpendicular to the river velocity. Suppose they will ask you the question with respect to river. With respect to river means you have to take 90 also. Total angle is 90 plus theta. With respect to river. Okay. Find the angle made by the swimmer with respect to river means 90 plus theta you have to take. Perpendicular to the river means you have to take only theta. Any doubt?
No, sir.
Right. Now this theta we are going to find out. How to find it? Now only I told you. So this is the river velocity, it is the man velocity. You take V man with respect to river. Means you make river velocity as 0. So river velocity, how you make 0? Means V water. So it is in this direction, you can add in this direction. Is it correct or not? So for water you can add here. These two gets cancelled. And for this vector also you have to add. Is it correct? So in this direction you have to add. This is V water. Parallel vectors. Here I can add it, here I can add it.
Yes.
So this is V man. Can you understand?
Yes, sir.
And this is V water.
V water.
And you can find this one also. It is A, B, C, assume it is. Now AB you can find out. So you know this is the hypotenuse is Vm and opposite is V water.
V water.
And this AB you can find out. So what is the AB value? See. So I am using this red pen. So this AB means along this perpendicular to the river, that is equal to root over Vm square minus V water square. Why? Square root of hypotenuse square minus opposite side square. Like this you can find this VA.
Velocity of water V to C is minus, no, sir.
Velocity of
Water.
V to C is not minus. Why? Because this is the water velocity. Very good question. It is the water velocity. I can add it opposite of that one. Why? Because these two are parallel. So plus or minus you can take directly. But here is, this is the man velocity, and for this I can add this water velocity. Resultant vector you have to take. Resultant vector. How? See here. Please listen. Suppose it is 3 meter per second. Please check here. 3 meter per second. And you take here 4 meter per second in opposite direction. Resultant is equal to, this resultant is equal to minus 1 meter per second. Directly you are taking. But now see here. Suppose it is 3 meter per second. And it is 4 meter per second. They are making some angle. So now resultant you have to take. The resultant is equal to root over 3 square plus 4 square plus 2 into 3 into 4 into cos theta. Like this you have to take. Resultant vector. Suppose it is A bar and it is B bar, making an angle theta with respect to horizontal. Then the resultant vector R bar is equal to root over A square plus B square plus 2AB cos theta. Can you understand?
Yes, sir.
So in previous case, rain and umbrella problem is there. No? In previous case if you check here, so this is the rain velocity I have taken. And it is the man velocity in opposite direction I have taken. What is the angle between them? 90 degrees.
90 degrees.
So resultant vector I have taken. So the resultant vector V rain with respect to man is equal to root over, actually it is VR square plus V man square plus 2 into VR into V man into cos 90.
Cos 90.
Cos 90 is 0.
0.
Because of that I have taken as VR square plus V man square in previous case.
Yes, sir.
Is it correct? See the previous case. Resultant I have taken root over V man square plus VR square I have taken. How I taken? Actually cos 90. Angle between them is 90 degrees. Any doubt regarding this?
No, sir.
Right. Similarly, here also this is one vector. You can add vector anywhere. It is one vector and it is one vector. It is hypotenuse and it is V water. That resultant you can take. That is AC square minus BC square will get. That is VM square minus V water square. Any doubt?
No, sir.
Pakka. Right, good. So now this is Vm square minus V water square. Now you know the width of this river, that is D. Width is D. Now they will ask you time taken by the man to reach exactly to the opposite bank. That time they will ask you. So you know velocity VAB So VAB, shall I write here? Where should I write? Shall I write here? So VAB is equal to, can you understand here vector I will tell. So VAB, you can take VAB. So VAB is equal to, means velocity is equal to distance by time. Distance is d divided by displacement by time. This time I want to find out, that is d by VAB. Is it correct?
Yes, sir.
That is equal to d divided by root over V man square minus V water square or V river square. This is the time. Suppose they will ask you the time. So time t equal to d by root over V man square minus V r square. This is the question. Okay, any doubt? Right. Shall we do one problem?
Yes, sir.
On this we will do one problem. Please check here. Please listen. Water is flowing. Water is there, no? So water is flowing with a velocity of 3 meter per second. Water is flowing horizontally with a velocity of 3 meter per second in the river. Okay. Width of the river is 10 meters. Width of the river is 10 meters. Okay.
Yes.
So, and the man is swimming. Man wants to reach exact its opposite bank, and he is swimming with a velocity of 5 meter per second. 5 meter per second. Then find number one, first one. Then find. Okay. Find the time taken by the man to reach exact to the opposite bank. I'll repeat the question. You see. The width of the river is 10 meters and the water is flowing in the river with a velocity of 3 meter per second. Man is swimming in the river with a velocity of 5 meter per second and wishes to reach exact to the opposite bank. Then find the time taken by the man to reach the opposite bank. Time you have to find out. That is the first question. Time taken by the man to reach exact to the opposite bank. That is the first question. So that is the first question. Time taken by the man to reach exact to the opposite bank. That is the first question. Second question is, what is the angle made by the man with respect to or perpendicular to the river? Third question is, what is the angle made by the man with respect to river? Three questions we can see. First we can find the time taken by the man to reach exact to the opposite bank is equal to d divided by, please do it, d divided by root over V man square minus V water square. That is equal to t equal to d means that is 10 divided by root over V man square, that is 5 square, minus V water square, that is 3 square. That is equal to 10 divided by root over 25 minus 9, that is equal to 10 by root 16, that is equal to 10 by 4. 10 divided by 4, cancel this 2, it is a 5 and 2.5 seconds. 2.5 seconds. So that is equal to 2.5 seconds. 2.5 seconds. So he will reach exact to the opposite bank with a time period t of 2.5 seconds. Any doubt?
No, sir.
Please ask me. No doubt.
No, sir.
So what is the time taken by the man to reach exact to the opposite bank? 2.5 seconds. 2.5 seconds. Okay? Right. Next question. Find the angle made by the man perpendicular to the river. Means this theta you have to find out. So that theta easily you can find out. So how theta is equal to c. So this theta means you write sin theta. No problem. Sin theta is equal to opposite side by hypotenuse. What is opposite side? 3. What is hypotenuse? 5. So theta is equal to sin inverse of 3 by 5. Theta equal to sin inverse of 3 by 5 means that is 37 degrees. Now only we saw 37 degrees. It is the small angle, no? 3 opposite small angle.
Yes, sir.
And adjacent 4 means that opposite is 53. And it is 5 means it is 90. Like that we can remember. So this angle is 37 degrees. What is this? This is perpendicular to river. And with respect to river they will ask. So perpendicular to the river is 37 degrees. And third question is with respect to the river. With respect to the river. With respect to the river. With respect to the river means you can add 90 also from here onwards. 90 plus theta. So 90 plus 37 degrees. That is equal to 127 degrees. So with respect to river is 127 degrees. With respect to river is 127 degrees. Okay. So this is one problem. Okay. Right. Thank you.